Okay, back at it again with section 8-2, and today we're going to zoom in and talk about just similar triangles. So 8-1 was about similar polygons just in general, like all of them, and this is just specifically about triangles, okay? So to start off with, I'm sure you guys remember those 5 congruency theorems that we talked about. We had side, 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 angle, side, angle, side, angle, 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 side, and then I think we also had HL, correct? Well, in this similarity chapter, we have 3 common similarity theorems or similarity postulates. And you're going to think that they're just like the congruency ones, but they're not. They are slightly different, okay? And the first one is called the angle-angle similarity postulate, all right? And it says if 2 angles in one triangle are congruent to 2 angles in another triangle, then the 2 angles are, or I'm sorry, the 2 triangles are similar. Now remember, similar and congruent are 2 different things. So if all 3 angles, or in this case, if just 2 out of the 3 angles are congruent, then automatically all 3 are, which automatically makes the 2 triangles similar, okay? The side-side-side similarity postulate states that if all 3 sides are proportional, then the 2 triangles are similar. So if you don't know any of the angle measures, but all 3 sides are proportional, which is what we were kind of talking about yesterday, then those are similar, okay? And then last but not least, we have the side angle side similarity postulate, which states that if 2 sides are proportional and the angle in between is congruent, then the 2 triangles are similar. So as you can see, these similarity statements or the similarity postulates are very similar to the congruency ones, but they are slightly different because of the wording and because of the fact that they're looking for similarity and not congruency. Okay, so the triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other 2 sides, so basically if one side of your triangle is parallel, not congruent, but is parallel to a side that's intersecting the triangle, then it divides the triangle into 2 proportional sides, or 2 proportional halves, or however you want to say this, okay? So if I'm looking at it from that perspective, all of this stuff is now proportional to all of this stuff, meaning they have the same ratio, same scale factor. So let's just do an example problem here. It says in example 1 and 2, find the length of AB. Well, AB is right here. So let's see if we can find that, okay? Now, all of this stuff is proportional because these are parallel. Those 2 lines have to be parallel for this to be true, okay? So we can say that x over 6 is equal to 5 over 10. And then, again, you're just cross-multiplying and solving at this point. So if you divide both sides by 10, you'll get x is equal to 3, okay? And some people are probably thinking, okay, Ms. Scruggs, I can just use my common sense and look at that, because if 5 is half of 10, then this must be half of 6. And what you just did in your head is exactly what I'm trying to show by cross-multiplying. So you're doing it already in your head. You do this all the time and don't even realize it. Okay. Next, it says we need to find this side right here, side AB. So again, let's just set up a proportion. Let's say x over 7 is equal to 2 over 9. So this will give us 9x is equal to 14. And if you divide 14 by 9, 100% is going to be a decimal. I just don't know what it's going to be. Approximately 1.5 repeating. And it's okay to get decimals. Decimals are not always, ideal because you feel like you've done something wrong, but as long as you are, as long as you've got it set up right, then it could very well be a decimal. Okay, the 3 parallel line theorem. This is almost exactly the same as the triangle theorem. It just says that if there are 3 parallel lines that intersect 2 transversals, now remember, a transversal is just a line that's intersecting another line, then they divide the transversals proportionally. So that's just a lot of wording, meaning that all of this stuff right here all of this is proportional to one another. And the reason why, the reason why it's all proportional is because of the fact that these lines are parallel, okay? That kind of goes back to chapter 3, where we had those alternate interior, alternate exterior angles. Remember, those were only congruent if the two lines were parallel. So this kind of goes with that sort of thinking, except for we're not talking about angles in this chapter. We're actually talking about the length of the side. So let's be super careful and not get it confused, okay? All right, use the diagram to complete the proportion, or complete the proportion. Okay, no problem, except for my boxes are all over the place, but we can do this. UV goes with UW, so therefore XY goes with XZ. Okay, so just if you need to draw lines, but that's how you work it out there. Okay, XY, so that's right here, goes with YZ as blank goes with VW. Well, that would be UV. Okay, and I'll do the last one here in green. It says blank goes with Y or ZY as WU goes with WV. So, which part over here on the left is missing? That would be X. Why is it scrolling? That'd be XZ, not XY, XZ. Okay, so that's really all there is to it. And of course, if there were numbers there, you could swap out the letters and put the numbers and cross multiply and solve. Okay, the triangle angle bisector theorem. Try to say that 10 times fast. Triangle angle bisector theorem. This just means that if you have a ray, and of course, hopefully we know what a ray is. This is a ray going through your triangle. Then it's going to divide the opposite side into segments whose lengths are proportional to the other two sides. So that's a lot of big words that basically just means that this is going to be proportional with this, and this is going to be proportional with that. Okay? Or actually, it might be the opposite way around. You could set it up like that, but the way the fraction right here has it is this is proportional to this is proportional to that. Okay, either way though, let's get this worked out. So in number 6, we're going to say that this side is proportional to this side, so x over 5. Now since I started with x, we need to start with 9. 9 over 15. Okay, so we'll have 15x is equal to 45, and divide both sides by 15, and you should get x is equal to 3. All right, and last but certainly not least, and in record time, if I may say so myself, this last problem, it's going to be a little bit longer because there's a little trick that you have to do. When you're doing these, you have to make sure that you know this individual length and this individual length, okay? The only thing that I know right now is that this is B. I don't know what this side is over here. But I do know I could find it if I were to say 14, which is the distance of the whole entire side, minus B. Because 14 minus B would give me just that length, correct? So, be super careful about that. Make sure if they're giving you the distance of the entire thing that you have to do maybe the minus if you're looking for just part of it. But once we've got this done, you can say 14 minus B over B is equal to 6.75 over 9. Cross multiply, so 6.75B is equal to, and I'm going to go ahead and skip this step because hopefully you know, but you do have to distribute the 9 to both numbers. So 14 times 9 is 126 minus 9B. Okay, we need to get B on one side, so let's add 9B to both sides. That'll give us 15.75B is equal to 126. And then if you divide both sides by 15.75, 126 divided by 15.75, I'm doing this all on my calculator. Oh, you get a nice pretty whole number of 8. All right, make sure you do the homework that's online, and if you need any help, please ask me. If you have, if you're concerned that maybe you still need some more practice, let me know, and I can send you some more practice problems. And anything that I can do to help, please let me know, because I really want you guys to be successful while we're out and to learn as much as we can. All right? So see you later.